Alright guys, you are welcome to the online tutorial class. Once again, it's Mohammed. So today we'll be talking about Chem 1241, organic chemistry. Today we'll be looking in organic chemistry is the study of carbon and its compound, and then in one of the branch of organic chemistry is hydrocarbons. And in hydrocarbons, there are three types of hydrocarbons. We have alkenes, and alkynes. Although in alkenes we also have cycloalkenes and then straight chain alkenes, but they are all under alkenes. Then we have alkenes and alkynes. So now today we will be starting with what we refer to as what? Alkene. Alkenes, first of all, they are organic. They are hydrocarbons with carbon-carbon single bond throughout their structure. They are sp3 hybridized always, and then they undergo only structural isomerism with no geometric isomerism. And also the alkenes has a homologous series. Then they have a general formula of CnH2n plus 1 plus 2. H2n plus 2. For example, this is CH4. This CH4 is C1. So we have C, that means our N is 1, then H, 2N is 1, then plus 2, which is C, then 2 times 1 is 2, plus 2, 4, CH4. So this is the general formula for alkenes. Then this one is called the homologous series of alkene. And in the homologous series of alkene, they also have their characteristics. One of the characteristics is they differ from one another by CH2. You see, if we add one H, it will be C2. Add one C, it will be C2. Add H2, it will be what? H6. So they differ from one another by CH2. As you move down the series, it will be increasing. Boiling point increases down the series. Melting point decreases down the series. Also, this molecular weight increases down the series. Then also, these compounds of homologous series, they have similar method of purification and similar method of preparation. Now, this is the first 10 members of the homologous series of alkene. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. It's very simple. You use, for the first 4, you use monkey eat peeled bananas. Monkey, butane. Eat, ethane. Peeled, propane. Banana, butane. Then from pentane, you use your normal plane shapes. Pentagon, hexagon, heptagon, octagon, nonagon, and decagon. So you see, pentagon, pentane. Hexagon, hexane. Heptagon, heptane. Octagon, octane. Nonagon, nonane, and decagon, decane. So these are the first 10 members of the homologous series of alkenes. So now we are now going to move into the nomenclature of alkenes. What do we mean by nomenclature? Nomenclature simply means naming of organic compounds, but specifically which type of organic compound? Alkenes. So, and in the naming of the alkenes, we are going to start with naming of the straight chain alkenes. That is the aliphatic alkenes, the aliphatic hydrocarbons, which are straight chain hydrocarbons. Now, in nomenclature, of alkenes, one thing we have to look at in nomenclature of alkene is it has rules. The first rule says you should always locate the longest chain. Rule number 1 says you should locate the longest chain. I don't have time to be writing them, so but as I say them, you get it down. Number 1 says locate the longest chain. So when you locate the longest chain, that longest chain is your parent name. Locate the longest chain, and that longest chain is your parent name. Now look at this. Now, to get the parent name of this compound, so we need to locate the longest chain. We have 1, 2, 3, 4, 5. 1, 2, 3, 4. So this one is shorter, this one is longer. So your parent name will be 1, 2, 3, 4, 5. What is carbon number 5? Carbon 5 is pentane. So your parent name here is pentane. Now look at this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So this one is the longest. Therefore, it is the parent name. 1, 2, 3, 4, 5, 6. So parent name for this compound is, what is carbon number 6? Is hexane. So we record it as parent name is hexane. Then the second rule. Every other element apart from the longest chain is called a substituent. Any other element apart from the ones in the longest chain is a substituent. Now let us look at this first one, still take it as our example. Now moving this way. Now, our parent, we say this is our longest chain. This is our longest chain. Meaning that this one now is not part of the longest chain. So since this one is not part of the longest chain, automatically it becomes a substituent. So what the rule number 2 is saying is, give the substituent the least number. Give the substituent the least number. That is, start counting such that the substituent will be closer to the side you are counting from. Because if we count from here, 1, 2, 3, 4, 5. If we also start counting from here, 1, 2, 3, 4, 5. So let's locate, where should we start counting from? You should start counting from the side that is close to the substituent. 1, 2, 3. 1, 2, 3. So you can start counting from any side of this because both of them, the substituent is at position 3. But look at the second example. Look at the second example. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3. So you see, counting from this side is closer. 1, 2, 3, 4, 5, 6. While counting from this side, 1, 2, 3, 4, 5, 6. So checking the position of the substituent. When you count from here, it is at position 3. When you count from here, it's at position 4. So that means we will not start counting from here. We should start counting this way and not this way. So therefore, now this numbering is correct, while this numbering is wrong. So that is what the second rule says. The rule number 3 says, when you are naming a substituent, what the rule is saying is that when you are naming a substituent, if it is a methyl group, alkyl group, alkanes are named as alkyl. That is, you should replace the ending ANE with YL. So now, of the corresponding compound in the homologous series. Now look at this. This is our example. So this is 1 carbon. So since this is 1 carbon is what? Methane. So you replace the ending ANE with YL. So that's, since it is serving as a substituent. Whenever an alkane is serving as a substituent, you replace the ending ANE with what? YL. So this is just 1 carbon and it's serving as a substituent. Instead of methane now, it becomes methyl. It becomes methyl. So the substituent here is methyl. So look at this one. 1, 2, 3. So all this is parent name. Now that means this is the substituent. In the substituent, how many carbons do we have? 1, 2. So we have 2 carbons. Since we have 2 carbons, what is 2 carbons called? Ethane. So now you replace the ending ANE of ethane. You replace this ending ANE with what? YL. So it becomes ethyl. It becomes what? Ethyl. So now you replace the ending ANE by what? YL. Then the next rule says, when naming a substituent, you should indicate the number where the substituent is present. Like now, we can't just say methyl. Where is it located? 1, 2, 3. It's located at position 3. So we say 3-methyl. So you say 3-methyl. Huh? So when there is more than one, you use 3,3-dimethyl, 2,3-dimethyl, 1,2-dimethyl. When it is 3-trimethyl, tetra, and so on, when they are more. Then another rule is, between numbers and numbers, use comma. And between numbers and letter, use hyphen. Between number and number, use what? Comma. Between number and letter, use hyphen. Then finally, when naming a substituent, you name them alphabetically. You name them what? Alphabetically. And when you are naming halogens, you name them as halo. That is, replace INE with O. If it is chlorine, replace this INE with O, it becomes chloro. Fluorine, fluoro. Iodine, iodo. Bromine, bromo. Now, these are the rules for nomenclature. So let us see some examples and practicalize the naming and see how we can do something reasonable. If we can name like 3 or 4, we are okay with the nomenclature of alkenes. So now, let's say we have something like this. So let's name these 3 compounds. If we are able to name them, then I think we are okay. So now let's see. We start our counting. We say we locate the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So anyone, we can take it as our longest chain. So let's take 1, 2, 3, 4, 5 as our longest chain, meaning every other thing is a substituent. This is a substituent, this is a substituent, and this is a substituent. Now, what is our longest chain? 1, 2, 3, 4, 5. So our parent name is 5 is pentane. Oh, our parent name is pentane. Now let's locate the substituent. Remember, they say give the substituent the list number. 1, 2, we need substituent. 1, 2, we need substituent. But this one, we have 2 substituents. This one, we have 1. Or you can use this method. 1, 2. Put 2 plus 3, 4. How many do we have in 4? 2. So we say 4 plus 4. 2 plus 4, 6. 6 plus 4, 10. Now check the other way. 1, 2. We have 2, 2. So you say 2 plus 2. Then 3, 4 plus 4. What will it give you? 2 plus 2, 4. 4 plus 4, 8. So which one is shorter? So you see 8 is shorter than 10. So you consider the 8, not the 10. So, but in a simple manner, once you just see this, these ones, there are 2 by this side, this one is 1. So consider the side with 2, not the side with 1. So when this place is 0 and this place is 1, you consider the place with 1. So now, from here, we are starting our counting from here and not here. So 1, 2. On carbon number 2, I have what? A methyl group. How many methyl groups do I have? I have 2. So on the same carbon number 2, I still have another methyl group. Then on carbon number 3, nothing. Carbon number 4, I have a bromine. So I say 4, I have what? Bromine. Bromo. Now I am going to name them. Remember, we say name alphabetically. So which alphabet comes first between B and M? B comes first. So we say for between numbers and letter, use hyphen. So hyphen, bromo. Now we have 2. This is methyl, this is methyl. So we join them together and call it dimethyl. Carbon number 2, carbon number 2. So we say between number and letter, hyphen, 2. Between numbers and numbers, comma, 2, comma, 2. Right? How many methyl? 2. You say di, methyl. Then what is the parent name? Pentene. Then you attach pentene. So you have to be careful. This is the name. You have to be careful. Do not give space between the last substituent name and the parent name. So you mark them together. So this is the name of this compound. So let's try the second one. Feel free to pause the video and try yourself. Then play the video back again. 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5 is the longest. So we consider 1, 2, 3, 4, 5 as the longest. So our parent name, 5 is what? Pentene. Then let's consider the substituent now. 1, 2, we need substituent. 1, 2, 3 before we need substituent. So we consider this one. So 1, 2. In carbon number 2, I have iodine, so it becomes iodine. Then 1, 2. In carbon number 3, look at it. This is a methyl group, this is another methyl group. So I have in carbon number 3, I have carbon number 3, I have methyl. In that carbon number 3, I have another methyl. Then that's one. So let's name alphabetically. I and M, which one comes first? I comes first before M. So we can say 2 iodine. Then 3 and 3. 3, 3. Dimethyl. Dimethyl. Then what is our parent name? Pentene. This is the second one. Now let's name the last one. 1, 2 we need substituent. 1, 2 we need substituent. But this one has more than this one. So we consider this. We consider counting this way. Remember the longest chain 1, 2, 3, 4, 5. So our parent name still is what? Pentene. Then now we have 1, 2. On carbon number 2, I have bromo. On the same carbon number 2, I have another bromo. Then on carbon number 3, I have chloro. On the same carbon number 3, I have a methyl group. Then on carbon number 4, I have a chlorine, chloro. So now let's combine it and name it. Which one? This is B, this is C, and this is M. So which one comes first? B comes before C. So we say 2, because we name alphabetically. Always remember between number and letter, hyphen, between number and number, comma. 2 bromo. But here we have 2 bromo. So there are 2 here. So it will be 2, 2. Then what? How many bromo? 2. It's now di-bromo. 2 di-bromo. Then we have chlorine. How many chlorine do we have? 2. In carbon 3 and carbon 4. So we say 3, 4. There is in carbon 3 and there is in carbon 4. 3, 4 di-chloro. Then what again? 3 methyl. Then what? Our parent name, pentene. So one last thing we have to look at is sometimes you can be asked, you may not be given the structure to name. You may be given the structure, you may be given the name, and they will ask you to locate the structure. So let's see if we can try that. Now this is, when we ask you to locate the structure, just go to the last name. What is the last name? Pentane, right? So you draw it. 2, 3, 4, 5. Then 4 bromine. 1, 2, 3, 4. On carbon number 4, you place bromine. 2,2-dimethyl. On carbon number 2, 2, all untitled. Dimethyl. So you see, this structure is the same as this structure. Just turn it like this and you'll see. Now look at this one. The last name here, let me take this last one we just did. The last name here is pentane. So 2, 3, 4, 5. Pentane. Now 2,2-dibromine. 1, 2. 2, 2. Dibromine. Cool? 3, 4. Carbon number 3, chlorine. 4, chlorine. Then 3-methyl. Carbon number 3, 1, 2, 3. 3-methyl. So you can see this structure is the same as this structure. So you can be given a name to convert it to a structure, or you can be given a structure to produce the name. So this is the little we can say about the straight chain alkenes. In our next class, we'll talk about cycloalkenes, and then we'll talk about the nomenclature of alkenes. Assalamu alaikum wa rahmatullah. Thank you all for listening. Once again, Salam.